Okay, so here it is lesson number 8, unit 5. And the goal of the lesson is to figure out how do we select something called scale factor. So right now you may be confused, what is this scale factor? So we'll see, we need to figure out scale factor so that the height, age fits the bridge. Now this is, even though it looks like black color is the bridge, okay? So just assume that this is the bridge. It's called Hulme Arch Bridge in Manchester, that's in London. The bridge is in the shape of a parabola. So it starts from the origin. You can clearly see it starts from the origin. So this and left end is put at the origin. And then it goes up. The height goes on increasing. Let me take this, we don't need this. This is just for an example. I said at the distance of 15 meters from the left arch, there will be height. So you're supposed to, so there's a maximum, there's the highest peak, this is the highest point. The highest point, we also call it maximum height. And that's, so the question is, by just looking at it, if you see that 52 minus, so let's see, first question is, what do you think is this? Tatiana, can you read this quickly?
A bridge in London.
Loud and
A
slow.
bridge in London is a parabolic shape. The ends of each are 52 meters apart and 52 meters high.
So he already gave you the answer also, right? So can you tell me what should be this coordinate? Jaylin, can you help me fast quickly? What should I write here? Huh? No, here, the origin. 0, 0, correct? So that's what they're asking you. So 8th question, find the 3 coordinates. So the first one is 0, 0, okay? And I'm going to write 1 here. And the last one, what is the last one here? Miguel, what should be this? Just the end point. By the ends of the arch are 52 meters apart. Now remember, this is the left end of the arch. This is the right end of the arch. So, what is this point? 52, and what else? 0, very good. So that's 52. So far so good? Nobody say yes. And what about in between? What do you think is this point here? How high is it? 25? Yes or no? So this 25, the second number is 25. Correct? And the first number will take, because this is 52, can you see this 52? What's half of 52? 52 half is, deck of cards is 52. So if two students are playing, each one gets how much? Katyana? You play cards, right? You never play cards?
26.
It takes so much time to think over that. Because when you play the cards, each one gets 52, right? I mean, 26 is 52. So that's 26. So that's 26. Is that okay? So the height, the maximum height is 25 when this point is at a distance of, so it's like from here to here is 26. And from here to here is also 26. Make sense? Correct, no? Cesar is okay? Daniel? Dalitsa? Make sense so far? Then the next question is, Haley, what she thinks is, she thinks of, oh, the polynomials we learned, we can create if you have a parabolic thing, it goes through those 2 points. So she sees, okay, she says, oh, develop one of the zeros are, so the graph crosses the origin, so the x coordinate here is 0. So she thinks that 0 is 1 point, and also the x-intercept where the graph hits the x-axis here is 52, so 52. So there are two numbers here, 0 and 52. So what basically means, so if these are the zeros or the x-intercepts, you can create a function like this hx. So she creates a function h of x and writes x times. How did she get x times? It's because it is x minus 0. So one of the point which goes to the x-axis is 0. And the second one is, in place of x minus 52, she writes it as 52 minus x, because it's like downward, It's like the parabola is downward here, concave down, opens down. So instead of writing x minus 50, this should have been x minus 52, but she chooses as 52 minus x, because it is going down. You need to have a positive height, right? Yes or no? The height has to be positive. So she doesn't use this, she uses 52 minus x. So each of these things are very important. So far so good? 3-4 weeks left. Just 4-5 weeks and we are done for the school. Okay? So let's respect it. So the question is, she chooses this to represent the height above a point x. And what is x means? It is so many meters along the base of the arch. So the down is the base. This is the base from left to right. The first question is, so we have to answer 3 questions, 1, 2, and 3. Let's ask Kimberly. For x coordinates of 3 points. Okay, I think we forgot to write here, right? This is 26, 25. This is 26, 20. Write down there. Now for each of the x coordinates, so which are the x coordinates? X is 0, x is 26, x is 52. These 3 x coordinates, for x coordinate of 3 points, what are the corresponding points on the graph of h? Now when I say h means Haley, not the actual bridge. She created a function, and so we wanted to know what is that height for those 3 points. Make sense? So all you do is plug it in. So we'll plug x is 0, so let's put it right here. I'm gonna write, use a color. So let's write so h, so height h, that's right, h at first one is 0. So I'm plugging in first one is x is 0. So those are the 3 points, remember? So your 0, so these are the main points, 0, 26, 52, you plug it in Haley's equation and see what happens. So you put a 0 equals 0 times, bless you. So I'm going to write 0 times 52 minus 0. And anything multiplied to 0, remember anything is multiplied to 0 is 0, correct? So it looks like so far it looks good. It is correct, 0, 0. So this point, so the first one seems to be correct. So Haley's point matches the actual bridge. What does this mean? Haley's, so 0, 0, you get, so here the answer is, you started with 0 and you end up. So when the input is 0, the output is 0, and it really matched what the actual bridge starts. Then the second question. Second, you plug in h. So I'm going to use h of, this time, I want to plug it in the 26. So this 26, let's put it 26 right here. and see what's going on here with this 26 equals the 26 because x is 26 times 52 minus again 26. So what do you get? So if you multiply 26, so you should get the answer. Can you work it out and see what are the answers you get? So 52 minus 26 is again back to 26, so it is like 26 times 26. And if you multiply, do little calculation on the rough sketch, you get 676. You can check out. I can make a mistake. I want to make sure you get it the right one. But the problem is, so this one, so the point is, so with this, the point is when you started with the x coordinate is 26, we ended up with 76. But does this point match the actual point on the bridge? So this is what she got, but does this point matches this point? No, see? This 676 meters is almost like, oh my God, it's almost like, how many times bigger, 25 meters, this is 25 meters, but the Haley, the way she created a function, that is like 4 times 4 times 4, almost like 24 times high. Way up, I'll have to break the roof and go up in the sky. Don't end. Okay, so this seems to be a stupid number. It doesn't fit. The actual number is 26 and 25, right? So the height at the bridge is 25. How can you have 676? That's too much. So something has to be done. That's the lesson is about what is that to be done. How can we shrink? How can we bring that point, Haley's point, to the actual height here? What change can we do to the function? Is there a way out to do? And the last one, let's put the last part, h of the 52. Let's put 52. Equals 52 times 52 minus 52. And what is 52 minus 52 is, this is 0, so that's 0, and answer is 0, so that means the point is 52 and 0. And that's exactly the same, look at this. So this point seems to be okay. So this point matches. Okay? And this point also matches it. But the middle one, no. How many of you are with me? Thumbs up. Who are with me? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, good. I know because nobody goes so deep. The way I'm doing all this, it's like really seeing, hey, what is this lesson about? How maths is relevant to the bridges in the London kind of thing, correct? It's just we do 100 problems, 1,000 problems, and we don't know what we are doing, right? Am I making sense? So there is some kind of connection to this. Oh, there's a bridge, and you want to create a function there. Yes? Were you not in my class freshman year?
Mm-hmm.
What is your name? Do you still quiet and serious? You don't smile, don't laugh? Okay. I still remember you were quiet and cool and calm. Thank you. Well, let me see whether they are there. Alexandra and Haley. Okay, watch this. Let's finish this, okay? So I'm giving enough time for you to just see. It's so cool, like, sometimes you wonder what is, what is this x, and this part is always a question. When I was a student sitting like you, I was just thinking, where the hell this is coming from, right? X and 52 minus x. Okay, and I remember we write the factor form. That's the main thing. If you have a graph, something like that, watch this. If I draw like this, there are 3 points here, 2 and 5 and let's say 7. We can create a function right here and say, okay, this is x minus 2, x minus 5, x minus 7. There it goes. That's what you create. You know those 3 points. The graph goes through 3 points. Though they are the zeros or the x-intercept, and you can create a function. You did that. But you can have another one. Watch this. You can have another one through the same 3 point. Look at this. Why only this? You can have one more this way also. Do you see? So there are infinite number of graph going through the same 3 points. Okay? That means when you create function like the f of x, then there has to be something multiplies to this point to go up here. This is 8, let's see, and this is 24, let's see. There is something that multiplies to the output here, whatever the 8 is the output. What multiplies 8 to get 24? That's the scale factor I'm talking about. So you see, I wrote here, what is the scale factor? So Haley fits the bridge. My question is, what aspects of the shape does Haley function model well? So it model well for what is the first point and the last point fitted, correct? Can you write down? For this one, you can write the answer as 0, 0, 52, 0, match. Haley's, the actual bridge, matches the actual bridge. But 676 is way up than 26, then 25. The actual height of the bridge is 25, but Haley's height is 676, and 676 is too high. Bless you.
Thank you.
Are you getting Tatyana? And now come the final nail in the box is compare the height of the Haley's graph with the height of the bridge. How can you change the output? So what can we do to this? Like this equation, how can we change this equation so that Haley's height is same as the height of the bridge? Okay, let's put it like this. If I try to graph this, we missed you, Eileen. This is a CCP time to tell everything what you did, okay? Let's finish this. Okay. So Haley's graph, this is the actual bridge, that's right. This is the actual bridge. You can't change the bridge. It's already done, it's right there. You can't break it, you pull it, and nothing you can do about it. But what Haley created this function, can we do something here so that when you plug in the 26, this 26, when you plug it in, it really gives you 676 back. And if you can tell this, right now I'll give you 4 points for the whole grade, 3 quarters. Whoever tells, that's what is learning about. Can a student get that part? Can you figure out what should I multiply here? I have to I'll put a box here. This is Haley did this, but just before that x, I have to multiply something here so that when you plug in the 26, this 26, it will match, you will get 25. Anybody would like to share? I know it is difficult at this time, but I did not show you, but if you can do this, that's great. Remember, let's put it like this. Even though I'm just trying to imagine, this is the bridge, right? And let's put it like this. Let's Haley, even though 676 is too way up, I can't go top there. Maybe I just say this is the bridge of Haley's bridge, okay? Watch this. And just imagine this is Haley's. And Haley's bridge is, this is 26, but she got 676 here. The actual one is 25, but this is 67, okay? The question is, how do I get this point here? I know here. Watch this, you can do it. This is the height, this is the Haley modeled and got that 676. But the actual height is, I want you to focus on this 25, and this 676. So what is that we have to, how do I get 676 to 25? What should I multiply to 676? Again, I repeat this question. What should I multiply to this output? So that's the output. And to get 25, so I want to get mu out. This is what Haley's output. But we want Haley's output to change to 25. So what should we multiply to the original one? And that is the lesson actually. This is called scale factor. We need to multiply something here so that when you plug in the 26 x's, you really get 25. Bless you. You're tired? Anybody wants to try before I tell you? I know it is hard. You want to try this? So listen, the trick is like this. If you want to get 4 out of 4 right now, and that's a promise. The whole 7, all 3 quarters. I can just change your grade to 4. My only question is, what should I multiply to 676 to get this? To get 25. You want to try? What is she telling you? Is she telling you about this? Okay, tell. Okay, now I make it 3.5. It should be a fraction. You have to, you have to multiply a fraction. So what is that fraction? Miguel, you want to try? Iliana, correct? Did I say it right? HO, not there. Marcus, you last try, I'll give you. You always used to tell the answer. Can you try here? And off your phone. Oh, he's doing that division, I think. I know what he was not texting. He was trying to check what. And I don't want in decimal. Just tell me the fraction. That's it, Marcus. So that's what I want to write. Let's write this. This is the final part, and we are done. HX, and I'm going to give a room here to show. I have to write something here times x, and then that everything stays the same. The only thing is we need to put something here. Yes, Marcus. What did you do? Will you do some calculation?
I got 0.037.
3.5. What is your grade right now? 2.8? So promise is promise. He is absolutely correct. Tell me the answer. 0.0. Say it again.
0.037.
37.
26.
6. Give me the whole thing.
No, that's the whole thing.
That's it. Okay. But what did you do? How did you get this? Can you tell the whole class? You divided two numbers. Your answer is correct. Just tell me what was the division you did.
Oh, I didn't divide, I didn't multiply by decimal, I just went over.
Yeah. So this is the 25. What Haley's height is 25, right? No. The actual bridge is 25 height. Height is 25, correct? But Haley got it 600. That was two way up. So what you do? You just divide. So this is 25. Divide by 676. Were you thinking like this? It's beautiful. Maths is so beautiful when you connect to real life, right? So it is 25 divided by 6. So that's the fraction. Were you thinking? But you never said that. So this is 25 divided by 676. Done. And I put a box here. See this box? I asked, what goes in the box? That's the all learning is. This is called a scale factor, and it's called a vertical. So now this one shrinks. Can you see this point? It shrinks. It has to shrink. Vertical shrink. So this is called what is this called? Vertical shrink, because a fraction that is 25 over 676 is smaller than 1. Anything smaller than 1, it has to compress. Another word is used is compress. So you compress, the graph gets compressed, or it's called vertical shrink or vertical compression by a scale factor. This is that scale factor. Got it? What is the meaning of scale factor? When you change the output, you want to change the output 670 to 225. So you have to multiply something, and that something is called that scale factor. So what you learn is how does this number affect? See this number affects means it's like it's of course it is a 0 point when he did it 0.037x. So this 52 minus. It's the same thing, right? So kind of you have to have a number before outside. So whenever the thing is it's like k, it's like a times f of x. So in actual, whenever there's a number before that, that number decides whether it will be stretch or shrink. That's all it is. So right now in this problem, it was smaller than 1. You got a decimal point which is 0 point. Here it is smaller than 1, so it shrinks. But if it was bigger than it has to stretch. Make sense? Did you get something? Did you get something? Something, right? Because when Haley created this function, she forgot that there has to be some number multiplied. But she was almost there. She did a good job here. She got the equation x times 52. She did good. But she didn't know the number so that it really, when you shrink, it fits the actual bridge. Am I right? And that's the last equation we are done. Okay, so I appreciate, can you just put it off?